Okay, so just finishing up where we left off from Monday's lecture. So the final sort of philosophical issue that I'm going to cover has to do with the nature of the learning process. And more specifically, there are questions that have arisen about what the process of learning looks like. Is it something that's continuous? That is something that proceeds in a smooth, gradual sort of a way? Is it something that is quantitative? That is something that results from adding bits and pieces in? Or is it something that we would call discontinuous or stepwise? So something that has large dramatic shifts in characteristics or behavior types. Or is it qualitative? Is it something that we can't break down into numbers? So anyway, there are a lot of different takes on what learning actually looks like. And to make these more concrete, also, I'm sorry for the background noise. My cat has decided that this is the best time to start using her scratching post, so that's good. But to make these ideas about learning a little bit more concrete and like less abstract, let's look at an example of short-term memory. And so here, let's say that we're interested in measuring short-term memory in children. And so we make up a list of things for children to recall. So ball, dog, cat, tree, something like that. And literature has found that 4-year-olds can recall about 3 things on average, but as children get older, they can recall an increasing number of items. And so as a result of this gradual increase in both age and the number of items that are recalled, we might then conclude that changes in short-term memory capacity is the result of quantitative or continuous change, because there's a change in the amount of information that's recalled as the child gets older. But if we ask the question differently, we can actually describe the learning process in a different way. So continuing on with our short-term memory example. So we know that as children get older, they can recall more. And that might leave us wondering, are older children doing anything differently compared to the 4-year-olds? So the focus here isn't necessarily on, well, how much more are they learning, but what are they doing that's different than the 4-year-olds? And so when we look at children closely when they're, practicing these word lists and trying to recall them, we can see that the older children are able to not only quantitatively recall more items than the younger children, but they rehearse or they practice these items more times than the 4-year-olds do. So let's say that dog, cat, tree are the last 3 items on the list. Perhaps those are the only words that the 4-year-old is recalling. And you can see that's not really a very sophisticated learning technique. It's really just hanging on to, well, the last couple of things that were said. Whereas an older child, maybe a 6 or 7-year-old, might try to tell themselves a story, or they might, be repeating them more often than the 4-year-olds. They might be like ball, tree, cat, dog, ball, tree, cat, dog. And so this is what we would call qualitative change. And so the older children are storing this information in a different way. That is, the nature of their approach is different than the 4-year-olds. And so essentially this brings us back to thinking about, well, which one is it? Is it continuous or is it discontinuous? Is it quantitative or is it qualitative? And one way in which we have taken an approach to resolving this problem of continuous versus discontinuous is to talk in the terms of levels of analysis. And we'll actually be doing an experiment later in the semester in lab demonstrating this. And so this idea of levels of analysis is about a particular ability or learning process appearing continuous or discontinuous depending on the way that you are examining it. And so to kind of plant the seed in terms of you all being researchers in the lab, researchers, we end up sort of biasing ourselves towards one explanation or the other as a result of how we're choosing to define our dependent variable. So you might remember the dependent variable is the thing that we're measuring. It's the information that our participants are generating that we are then measuring and examining. And so if you're taking a quantitative approach, AKA, well, how many items can a 4-year-old remember? You're asking a different question and using a different lens to investigate than asking, well, how do 4-year-olds go about learning this information? Okay, any questions on that before I'm going to switch topics and we're going to move away from the philosophy and talk more about sort of the history of psychology that led up to cognitive psych. All right, moving right along. So there are a handful of influences that, like I said, led to the development of cognitive psychology from within the psychological field itself. And so one of these influences was from the verbal learning research tradition. And so there's a man named Ebbinghaus, and he was the first person to actually research verbal learning. He was really interested in studying learning like the behaviorists, but he didn't care much about animals. He really wanted to investigate more of how humans actually learn. And so to do this, he came up with his own scientific experimental method. So he used what we call list learning. So he had a list of, he made up these nonsense syllables because he didn't want to associate meaning with them. So instead of having a list of like cat, dog, rat, he just had a set of 3-letter words that weren't words at all. So like XRW, TVU, and things like that. And so he then had these 3-letter combinations of nonsense syllables that he was studying. And so he, of course, as many beginning researchers do in history, used himself as the subject. And he was trying to really be systematic about studying this learning process. And so what he would do is he would memorize these lists of nonsense syllables. And then once he could repeat a list twice without making any errors, so 2 perfect performances in a row, then he tested his recall of this list and he would vary it over a set of hours or days or even months. And so in order to measure his recall or his retention, he developed this what's called a saving score. I'm not going to go too into depth about it, but essentially it was a way for him to quantify his learning. And so what he did was he compared the number of trials that it took him to memorize the list in the first place, and also the number of trials it took him to re-memorize the list. And then the savings amount was what resulted when divided by the trials that it took to learn the first time. So essentially, this was his way of quantifying his dependent variable of, well, how do humans learn and what does learning look like? And so other researchers became interested in this verbal learning research, and they elaborated on them. And so there are some things that we'll end up talking about in the semester, like paired associate learning, retroactive and proactive interference. And the measurement of forgetting came out of some of this research. And so the verbal learning tradition, it was separate from the really popular scientific approach of behaviorism at this point in history. But it did borrow some things from behaviorism, but generally it didn't hold the same sort of assumptions that behaviorists did, and it certainly didn't emphasize animal research as much as behaviorism did. And so, so by the time of the 1960s, a lot of psychologists had gotten to a point where they thought that verbal learning theory wasn't quite enough. Sorry. Okay, so the cognitive psychologists, or the people who would become the cognitive psychologists, really became critical of the validity of these verbal learning studies, or the fruitfulness of them. So even though a line of research might be fruitful, it often resulted in trivial experiences or experiments, pardon me, and they didn't really add a lot to the body of knowledge about humanity. And similarly to that, we have the problem of ecological validity. So as we saw in Ebbinghaus's list learning task, he wasn't learning meaningful information. He wasn't learning information that carried any value to it. They were just random sequences of letters. And that actually doesn't carry over to people's everyday ability to learn and recall information, right? We normally don't try to remember nonsense words or nonsense syllables. Rather, we try to remember meaningful things. So the names of classmates, or when assignments are due, or what we need to get at the grocery store. It's usually information that carries meaning with it. I apologize. My body's decided that this is the best time to have a coughing attack, so that's good. But some things that cognitive psychologists did carry over into their field of study was the emphasis on human behavior, and human behavior being distinct from animals. The study of memory also, by using experimental method to study it. And they were really interested in trying to explain more about the learning process based on the verbal learning studies that had taken place. So another area of influence on cognitive psychology were the schools of thought that came before it. One of them called structuralism. And this is an approach that focuses on understanding mental experiences to be the result of the relationship, the interplay between the structures, quote unquote, of the mind. So you can kind of think of this as, if you've heard of the saying, the whole is equal to the sum of its parts. So this idea that, well, this idea of mind, this idea of thinking, is the result of these various structures just interacting with each other. That's what it means to think. That's what it means to have a mind. And so this was a very theoretical kind of approach. And in contrast to this was this concept of functionalism. And this school of thought cared a lot less about what made up the mind and more about what the kind of functions the mind could perform. And so this was a lot more applied. So rather than caring about, well, what are all the different sorts of structures? It was more about, well, what is the mind actually really capable of? How do we think consciously? How do we memorize things in a way that didn't emphasize, well, first, you have this structure of memory and it's made of these different components, and then, it processes this and that. So these two very different sorts of approaches. And so another influence that you might have heard of in other classes is Gestalt psychology. And this approach really emphasized the study of how we perceive the world around us and make sense of it. This is a school that eventually led to this idea that as our human brains, they have this just innate desire to construct a whole from its parts. And Gestalt psychology also involved the study of how humans go about solving problems, and found that human problem solving isn't fully dictated by the kind of learning that comes from trial and error. There is actually a subconscious sort of insight that's involved to it. This sort of eureka moment that you've all probably had. We're trying to figure out how to solve a problem or do a task, and maybe you step away from it for a bit. And as you're making dinner or running errands, all of a sudden you're like, oh, I know, I figured it out. I know what the answer is. And so that wasn't a result of you continuing to sit and try to solve that problem, over and over again. There's actually some sort of unconscious insight that was involved too. And so from these schools of psychology that preceded cognitive psychology, there were obviously some good, meaningful parts that cognitive psychologists really picked up on and carried forward. So one of them was from the verbal learning tradition. So this is the focus on people as participants as something that was important in opposition to the use of studying animals. And like I said earlier, this came from the idea that there are some human characteristics that are just different from those of animals. Of course, humans are animals, but at the same time, we have some characteristics and abilities that set us apart from non-human animals. And so the verbal learning researchers were able to study memory successfully by applying the experimental method. And this really opened up the way for researchers to start looking at memory and coming up with new ways of studying memory, as well as the study of consciousness, perception, Gestalt psychology suggesting that there is a need for a study of perception and problem solving, and as well as the verbal learning tradition also showed that there were just research findings that behaviorist learning principles couldn't help explain, such as the idea that our cognition is more complex than, like I said earlier, sort of this idea of the sum of its parts. So it's not just, well, A plus B equals C, and C is therefore made up of A and B. But there's a lot more complexity to it than that. And then, of course, too, cognitive psychology was able to develop a much more organized theory rather than the verbal learning tradition, which just sort of decided, well, hey, like, let's just do some experiments because we're interested in it, not necessarily because it's being driven by any sort of theoretical idea. And so, as I've alluded to, another important school of psychology that came before cognitive psychology was actually the dominant force in psychology before cognitive psychology came on the scene in the 60s, was behaviorism. And so this started in the early 1900s, and like I said, it really started to lose its adherence and its impact in the 1960s, which is when cognitive psychology started coming on the scene. Actually, the beginning of cognitive psychology is what's referred to as the cognitive revolution. And so behaviorism, again, some of you might have taken psych of learning, or you might remember this vaguely from your intro to psych classes. But behaviorism really emphasized the study of relationship between external stimuli and observable behavior. So this idea of stimulus response. Something happens in the environment, and because of that particular stimulus, an organism has learned a particular response. There's an association that's been formed between these things, such that every time a certain stimulus is encountered, say a piece of food, there are certain behaviors that that organism will always do, such as drool. And so behaviorism really wanted to focus on identifying a really small set of just general principles of behavior that they would be able to use to describe learning across all species. So they really took this sort of universal lens to the idea of learning. Well, all biological organisms learn. Let's find out the ways in which all of them learn. They must have all of these similarities since they're all biological organisms. And of course, like I've alluded to, behaviorists used animals as their research subjects primarily. And again, it's because of this idea and this goal of being able to find these general or universal learning principles that were done by all biological organisms. And so behaviorists, with the assumption that, well, humans are animals, just like all other non-human animals. So, you know, it's a lot easier and a lot cheaper to get rats or mice or pigeons in the lab. They're a lot easier to, incentivize, right? With humans, it's a little bit harder to get people in the research lab. But if you bring in a set of rats and you teach them, hey, your reward is a piece of food, great, that'll do it, whereas with humans, that's not always the case. And so anyway, because of all of these factors, behaviorists used animal subjects. And it was from these animal subjects that they then said, well, this then too is how humans behave. This is how they behave and operate in the world. So there was a lot of contention between the behaviorist tradition and what was to become cognitive psychology. The cognitive psychologists rejected pretty much all of the assumptions that the behaviorists held. And so the shift from behaviorism to cognitive psychology was really this 180. So some of the behaviorist assumptions that cognitive psychologists rejected was the idea that human beings are just passive reactors to external things in their environment. Essentially kind of this idea that humans are just, we're just robots, you push a button or you give us a certain piece of information and we act on it predictably. Another idea that was rejected by the cognitive psych folks is the behaviorist idea that human behavior can be explained by a set of learning principles that's identified by studying animals. Again, going back to this idea of, well, humans and other animals, they're all the same. They're all similar. They're all driven by the same sort of processes. There's no difference between them. And cognitive psychologists pushed against this. And they said that no, human behavior is, there are characteristics of humans that make them different from animals. And therefore, we have to study humans and not to study animals and assume that all of that applies to humans. And then another assumption that the behaviorists held that were then rejected is that learning can be studied in a meaningful way by studying external stimuli and responses alone. That's it. The behavioral psychologists had this idea of the mind as just this like inaccessible black box. They just thought, we can't even access what's going on in the mind, and it's actually not even about the mind. Again, this idea of, well, behavior is dictated by the environment. So we're going to focus on the environment and the responses a person makes. We're not going to try to, get in there and see what's going on in the mind. And the cognitive revolution then really shifted this and started really looking at, well, what is going on in that little black box that's so inaccessible? There is, some things that the cognitive psychologists did carry over from behaviorism. One of these things is that they did incorporate the really strong emphasis on experimental method to study what they wanted to focus on. So even though behaviorism was focused on the external, they still had really strong experimental research methods that the cognitive psychologists appreciated the emphasis on, and they just pointed it towards the study of cognition rather than the study of behavior in the environment. So there are some other influences in the field of cognition that I want to touch on here. So another influence was what's come to be called human engineering or human factors. And so during World War II, psychologists at the time found that behaviorism really had little to offer in terms of practical solutions to wartime problems that came up, such as pilot fatigue. Pilots are flying these long, strenuous missions. They're having to fly a lot of back-to-back missions. Also within soldiers, there was loss of attention or alertness, sort of dozing off. There were errors that were made during skilled performance. So you have these soldiers, these pilots who are really well trained and, they've got tons of hours flying, and yet they find that they're still making errors. And so most psychologists had concentrated on what we call basic research rather than applied studies. And so basic research is the research that's done in the lab with little thought for how it can then be applied and used in everyday sort of life. And so these psychologists were having a really hard time when the government was asking them questions about real life problems that soldiers were facing on the battlefield and in their training. And in addition to this, what psychologists knew about the process of learning and most of the problems that were happening, like pilots crashing and soldiers shooting at allies, rather than the enemy, making like mistakes like that. This was occurring among the people who had already acquired the skills that they needed. So this was happening in folks who had accomplished the learning. They had acquired these skills, but errors were still happening. And so the psychologists were like, well, this isn't an issue with like the new recruits. This isn't an issue with like the newbies who just enlisted, this is also, there's still errors that are happening in our more advanced troops as well. So because of these two issues, psychologists, they really had to scramble at the time to figure out some other way of researching and thinking about humans. And so from the more physical based scientists, they borrowed what's called a system approach. And so the idea here was that the soldier and the machine that he was using made up a system. So whether it's the soldier and his tank, or the soldier and his gun, or Humvee, or plane, or whatever it is. And so within this idea, each component of the system, the man and the machine, had various characteristics. When working by themselves separately, they might work perfectly well. So, but the issue arose when the components were put together. So that is when the characteristics interacted, when the human and the machine interacted. And sometimes there were weaknesses that were created, or weaknesses that already existed that then became amplified. And so the idea was that, well, there are limitations in one or both systems. There are limitations in the machinery that we're using, or limitations in the men in our armed forces that is leading to errors or even disasters. And so there's one example that's described really frequently, and it's the situation in which a particular type of military plane had just this reputation for crashing on landing, which to me, I mean, I know you're supposed to obey orders and things like that, but I mean, if I were a soldier and I was being told to fly a plane that had a reputation for crashing upon landing, I would be less than excited about taking on that mission. And so, you know, the mechanics did an investigation. It was this whole thing, and it turned out there was nothing wrong with the plane in terms of its design, its aerodynamics, you know, anything like that. And so, for all intents and purposes, it seemed like it was a pretty well designed plane. And they couldn't figure out, well, what is the reason for this plane crashing repeatedly? And they also couldn't find any sort of pattern or trend among the pilots that would suggest, like, oh, maybe they need additional training, right? Maybe we need to refresh these certain skills, or anything like that. So really on its own, the pilots and the planes seemed like, well, they should be working perfectly. There shouldn't be any reason for these planes to be crashing when they land as often as they are. And so what we call the human factor psychologist found was that the problem was the result of an interaction in this system between the pilots and the planes. And so in these planes, as they were designed, there were two levers that controlled the wheels being retracted, being brought up, and then braking on approach, so slowing down on approach. And so pilots, the way that this is set up, the pilots had to identify the brakes by touch, because they had to keep an eye on the runway as they were approaching it. So they had to keep their eyes straight ahead, and then they had to feel down in the cockpit for the lever. And so because they had to, you know, do these things so quickly, the pilot would land the plane on the runway thinking that he had put the wheels down, when in fact he hadn't, or vice versa. He put the wheels down, right, thinking that maybe he was braking. And so the solution was redesigning the location of these levers, and also the way that they worked, that they moved, so that the pilot was then less likely to confuse the two of them when operating by touch. And so this redesign solved the problem. There weren't any other issues. Noah, did you have a question? Sorry, I just saw something pop up on my screen.
Yeah, sorry. So if maybe I'm being nitpicky, but
No, sure.
wouldn't that technically have been a design flaw with the plane then? If like, because this isn't this example supposed to illustrate how like two pieces can be working perfectly, but then together they can go wrong. So like, or am I missing something where that would be like that seems like it would be a flaw in the design of the plane.
Right. And so when they were considering these separately, so when they were looking at the planes themselves and checking, okay, do these levers actually work? Do they apply the right amount of force? Do these wheels come down properly? Mechanically, they're like, this doesn't make sense. We can't find a mechanical sort of explanation for why this is going wrong. And then, like you point out, it wasn't until that interaction happened of the pilots using them that it was like, oh, the mistake isn't coming from the mechanism of the plane or the skills of the pilot. It's coming from the interaction of the two.
Okay. Yeah. Thank you. Sorry.
Yeah,
Got
no,
it.
that's great. It's a great question. And I think it's sometimes hard for us to think about too, taking a sort of systems based approach like that when we're so used to this idea of, well, like, humans being integrated in the world and things like that. And it's much harder to break things down into component pieces like that and think about it, um, you know, that how do we fully divorce the human aspect of it from the machine operating? So yeah, great question. Okay, yeah, so they redesigned where the levers were, and lo and behold, there weren't any more crashes with those planes. So from what this human factors research with the military brought about, so cognitive psychologists, they said, okay, the applied side of this, that's great, that's important, but it's not based on any sort of theory, right? You're just seeing a problem in the world and fixing it. You're not really saying, oh, well, we know why this happened on a larger scale. But there were some aspects of human factors research that cognitive psychologists really liked and incorporated into their own field of study. So this included the idea of human beings being decision makers, rather than sort of, again, going back to behaviorism, this idea of humans as just passive reactors. And also led to the importance of understanding how humans behave, that is, how humans perform within their context. So it's not enough to just look at the person in general and how they perform, but what is going on with the interaction with their environment. And again, in contrast to behaviorism, so there was this emphasis of, well, humans aren't just passive, they're actually active processors of information. And so I'm just going to go a little bit more into depth about behaviorism, and then we're really going to compare and contrast them against cognitive psychology. Because like I said before, there was really this big shift from behaviorism to cognitive psych. And so behaviorism, it says, like I said before, that the goal is to identify general principles of behavior. Another assumption, and this might sound familiar, John Locke and empiricism, is that humans are born tabula rasa or blank slate. So again, this idea that we are really just blank slates that the experience of life writes on, and that's then what makes us unique. We're not born with anything inherently unique to us. And also this encompasses the idea that, again, we're passive reactors to the environment. And for psychology to be a science, behaviorism also thought it was, or behaviorists also thought that it was necessary to study observable behavior using objective scientific methods. And so in this instance, objective means the things that we can see, aka behavior. And so again, reinforcing behaviorism's emphasis on the study of behavior and not wanting to go anywhere near this idea of mind because it cannot be observed. Another core assumption was the principle of association is enough to explain all behavior. So that is, when two things are occurring together in space and time, there's a link or some sort of association or bond that is formed between them within the organism's response patterns. And furthermore, that complex associations are the result of just cumulative simple associations. So sort of complex associations are built by the blocks of simple associations. And like I said before, the focus is on environmental influences or stimuli on behavior or responses. And like we talked about before, we can generalize from the simple to the complex in terms of behaviors and also organisms. So we can study animals and we can generalize that to humans. Now, in contrast, cognitive psychology's assumptions. So the primary goal of psychology is to understand human behavior. And this is done through the study of mental processes. Cognitive psychologists believe that mental processes exist. We can study the mind. And that understanding mental processes, this is the key to understanding many behaviors. So the assumption is that people don't respond exactly the same way to the same stimulus. They process information differently and they apply it differently. And so by understanding the underlying mental processes, then the hope is that we can better predict people's behavior. And accompanying this is the idea that, like I said earlier, humans are really active in participating in the world, processing information. And this allows for people to be selective in the information that they attend to integrate information that they've just learned with old information, to make judgments about two ideas or two pieces of information, or things like that. Cognitive psychologists also hold to the experimental method, but they do acknowledge that it's not a guarantee of objectivity. But they said that mental processes can be studied scientifically because they do occur according to rules. So mental processes aren't just random, you don't just have a random memory come to you, but they are events that are repeatable that we can replicate once we have identified the rules and the conditions under which they occur. And so because mental processes, they take time to happen and they happen with measurable sort of accuracy. So an example is of measurable accuracy might be going back to a list learning task, right? We can measure, okay, how many of these words did you accurately remember? Or we can time somebody on a task, right? And we can say, oh, it took you 39 seconds to complete this task. And so there are ways that we can still measure these mental processes. And they can also be inferred by just observing someone's behavior, or the other, what we call end products of mental events. So we can see the outcomes of mental events, and we can still use really strong scientific methods to examine this as well. There's also this idea of what's called convergent validation. So this is the use of different kinds of methods to see if the same results are produced. So testing somebody, on a Monday morning, testing somebody on a Wednesday evening, testing somebody through like auditory means, like using a speaker versus having them just read over things. There are different ways that we can investigate the same sort of issues or phenomena to see if we get the same sort of results. And then another big one is that learning is more than just the behaviorist idea of these little building blocks of associations. There are really a lot more steps and pieces to it than just that. And so the various steps that happen cause information to be transformed in various ways. And so that is something that makes it much more complex. It's not just, well, A plus B is C, but really C then categorically becomes something different than A and B. Another emphasis is on the subject matter of psychology, and that it should be focused on the understanding of mental events. So these are things like problem solving, language acquisition, and language use, decision making, judgments, short-term and long-term memory, knowledge, storage and retrieval, attention. That is the focus, these different what we call domains of cognition or areas of cognition. And there isn't this behaviorist assumption that human learning is exactly the same as non-human learning. Cognitive psychologists will concede, sure, there might be some similarities, there might be some relationships, but it's not this one-to-one idea that the behaviorists had. And therefore, the focus is on human cognitive processing. We want to know about humans, therefore we're going to study humans. We're not going to study animals and then assume, well, this is how a rat does it, so that's how a human does it. Any questions before I move on to the influences outside of psychology? Okay, I'm going to take the silence as no. Okay, so going back to World War II, when you take history and systems, you will see that World War II era was a huge turning point for psychology. And so as a result of World War II, psychologists during that time were exposed to a number of different perspectives of human behavior that were really different from the behaviorism perspective. So like we talked about before with human factors and the planes and pilots example. And so because of this, psychologists were really starting to consider new ideas about human behavior. And one influence came from this field of communication engineering, or what became called to be called information theory. And so information theory was a field that developed partially as a result of World War II. And so this is focused on the idea that there are devices that transmit signals like phones and radios, and that there is an issue that can arise in the form of information being lost or disrupted between the input of the signal and the output of the signal. So essentially this idea that, these devices that transmit signals, they're not doing it with 100% certainty or accuracy. And there can be lost or transformed information that comes out of background noise, maybe faulty components, like a fuse has gone bad or the wiring has gotten loose, or even interference from other devices. And so thinking about this, it's kind of like the game telephone, where one person starts with a statement or something like that. They whisper it to the next person, they pass it on. Um, and usually the last person says something that is totally ridiculous and very different or nonsensical in comparison to what the original message was. And so psychologists noticed that there seemed to be a similarity between communication devices like radios used in the war and humans. So this little metaphor of humans as, you can think about it as like walkie-talkies or radios. So as people, we take in signals or messages. And therefore we're like communication channels. And we can transform those messages, we can pass them on verbatim to others. And like radio devices, there can be noise, quote unquote, or faulty components or interference that then causes error in human communication. So information theory provided a sort of rough metaphor for psychologists to describe and explain and understand mental processes. And so, well, how did this contribute to cognitive psych? And so this is especially seen in the area of the domain of attention. There are terms that psychologists borrowed, like channels, information processing, filters, limited capacity, serial and parallel processing, which as we go through this class, these words will become more and more familiar to you. And so another influence outside of psychology was then the development of computers and the area of computer science. And so again, psychologists found computers to be another great analogy for the way that humans work, or human mind works. So both computers and humans process information. They take in information from the environment. They can manipulate information, store information. They can create a product, a printout or an action or something like that. And so given these similarities, psychologists were like, hey, you know what, we can actually use the concepts of both computer hardware and also software as a model to describe and explain how humans think. So this sort of idea of, memory as the hard drive and things like that. And so again, there's then these ties between the human mind and even the components of the computer. And so this contributed to cognitive psychology. Again, this analogy of computer hardware as describing the way that we store sensory information, how our short-term memory works, how our long-term memory works, and also the way that software and computer programs work are assumed to be pretty similar to the ways in which our mental processes work. And also, computers were not just an analogy for the way that humans think, but then they also became a way in which we could measure these mental events. So for example, being able to measure really precisely, like down to the millisecond, how fast somebody presses a key response. Or even as you'll all experience in the lab, we're using computers to take these tests, to receive these stimuli, to respond to things. So you'll see that not only this idea of computers being big in terms of being analogous to human cognition, but also seeing that computers play a really big role in cognitive research as well. And then a final area of influence was that of linguistics. And so this is the study of language. And this was a shift from the behaviorism to the linguistics field. And so linguists and behaviorists, they both studied language, but they were really opposed in their assumptions. So behaviorists, of course, tried to explain language from a stimulus response kind of view, this idea of, well, reinforcement is what causes language to be acquired. Whereas linguists, they really, emphasize, well, it's about, the novel aspects, the new aspects of language, how complex language is, how language is produced, how language is organized, the fact that language has rules. All languages have a grammar and a syntax to it. There are rules that define the way that it operates. And so these linguists then hypothesize that, a lot of language knowledge that we have is innate. There's this sort of pre-programming for acquiring language. And this idea really, this was really a turning point, or there was a turning point for this idea. And it was in Noam Chomsky, who's a renowned linguist, his review of Skinner's book, he really roasted him, honestly. And so he said, look, Skinner, you are just taking these behaviorist terms and applying them without any evidence of how it's actually happening. Another thing is that he pointed out that there seem to be these universal aspects of language that can't be explained by stimulus response. So kids from cultures all over the world begin to acquire language at the same time. And the majority of language acquisition processes look very similar in kids across the globe. And so if it was this stimulus response idea as put forth by Skinner, then there should be these big differences between cultures and ages and things like that. And so because there aren't these big differences, it's clear that the environment and, this idea of stimulus response, reinforcement, doesn't play as much of a role as Skinner was saying that it was. And so this was also important because this gave psychologists who really weren't on board with behaviorism the sort of permission to go ahead and use a different lens to study humans and other aspects of human behavior. And so I'm aware of the time, and so that's where we're going to stop for today. Does anybody have any questions on what we've covered today or anything that came up in the reading?
Just on this last slide, would you
Yeah.
say the Broca's and Wernicke's area would support the linguistic view, and would modern research show that it is innate and it is a part of our mental processing?
Yeah, great question, Julia. Yeah, definitely. I think that that's another piece, that neuroanatomy piece that you bring up of Wernicke's and Broca's, for example, right? These universal language centers that are a part of the brain and also go along with the linguistic idea of we're pre-programmed for language, that language is innate. So we are born with structures in our brain specifically for language comprehension and language production. And that, in addition to the fact that there's this universal development, that whether you are a kid in China who is learning to speak Mandarin, or you're a kid in France who's speaking French, you're learning that language particular rules, and you are learning the rules at a similar sort of pace. There's these sort of developmental milestones, we call them, of, oh, this is about when kids start saying their first word, regardless of the language. This is when kids start to say sentences, maybe a couple of words in a sentence and things like that. And so again, yeah, if it was the case that the way the behaviorists saw it was what was going on, then we would not see a lot of these similarities, these universal experiences across the board. And also, like you point out, there wouldn't the discovery of things like Broca's area and Wernicke's area and these other structures of the brain that also, you know, the behaviorists, right, they didn't focus on the mind or the brain. All they focused on was behavior. And so being able to incorporate things like neuroanatomy, like Broca's and Wernicke's, really also boosted the linguists' pushback against behaviorism as well.
Thank you.
Yeah. Any other questions? All right. Well, I know that was a good amount of philosophy and a lot of history. But again, just hoping to give you some sort of framework in context for, well, why does cognitive psychology use the words that it does, care about the things that it does, ask the questions that it does, just sort of help maybe make some of the more abstract aspects of cognitive psych a little bit more understandable. It's at least my hope. So, all right, well, thank you all so much. I hope you have a great rest of your day. I will see you all in lab. I'll be a little bit late because I have a meeting, but I'll pop in and I can serve as a brainstorming resource for you as you and your partner start thinking about what kind of research you want to do this semester. All right, everyone. Yeah, thank you all.
Thank you.
I'll see you later this afternoon in lab. Bye.